Welcome to this presentation on the Automic Airflow integration solution. We want to take this opportunity to explain what the integration brings to the Automic user community. In our efforts to develop new solutions to support cloud operations, the Airflow integration plays a significant role in the automation of various types of workflows in applications like AWS and Azure. The Automic Airflow integration brings several key benefits to cloud operations managers. It makes it possible to delegate automation to a platform dedicated to workflow management, centralizing and simplifying the entire process and make it more fluid and transparent. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and DAGs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizes these processes with other non-cloud operations like ERPs. Instead of relying on Airflow workflow management, we can configure process automation centrally in Automic and then trigger, monitor, and supervise all in one place. Airflow workload can then be synchronized with other environments routinely supported by Automic, like applications, databases, and ERPs. Airflow's role is reduced to storing DAGs and submitting them to the cloud solutions. All other functions, especially those pertaining to automation, are delegated to Automic. Airflow lacks the ability to create dependencies between DAGs, and a single DAG job can become long, complex, and difficult to manage, update, and restart. Automic Automation can break up a workflow into multiple sequence DAGs, making workflows more manageable and auditable. Designing DAGs in Airflow requires coding proficiency. By contrast, Automic lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an ops perspective, Automic seldom requires any knowledge of computer programming of any kind. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple ERPs, multiple database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agents. The agent is configured with a simple INI file containing standard values, AE system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository, a connection object to store the Airflow instance's REST API, and a job template designed to trigger DAG jobs. Let's assume we're automating for 4 instances of Airflow. We create a connection object in Automic for each instance by duplicating the con templates for each of these instances. Lastly, we create DAG-type jobs in Automic for each corresponding DAG process in Airflow. The Automic jobs include the connection object based on the target system. When we execute the DAG job in Automic, it triggers the corresponding DAG process in Airflow. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job report. In Automic, this DAG job can be incorporated in workflows and integrated with other non-cloud processes. The procedure to deploy the Airflow integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip the package, which produces a directory containing the agents, the INI configuration file, and several other items like the start commands. We use the appropriate INI file for our specific platform. Airflow is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic system, JCP connection, and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every Airflow instance we need to support. For this, we use the template con objects, which we duplicate as many times as we need. The con object references Airflow's REST API URL. Finally, we use the template DAG job to create the jobs we need. We match this Automic DAG to the Airflow DAG, reference the con, and run it. We're able to supervise the DAG and its children, generate logs, and retrieve the status. The DAG can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Airflow integration. The agent is included in the Airflow package, which we download from Marketplace. We unzip the package, which creates a file system, agent/airflow/bin, that contains the agent files. Based on the platform, we rename the agent configuration file ucxj-citx and set a minimum of 4 values: the agent name, the AE system name, the host name, and port connection to AE's JCP, and finally the directory containing the TLS certificates. Finally, we start the agents by invoking the jar file via the Java commands. The agent connects to AE and deploys the object templates needed to support the integration: the con or connection object and the DAGs job templates. We have a connections folder. We open it and create an Airflow connection. The endpoint is the REST API URL, and you should not include the DAGs folder. We'll use the basic authentication type, although you could use OAuth 2, and we'll enter the admin name and password. We head to the Jobs folder and create our Airflow DAG job. The Airflow Jobs object has the same pages as a regular system job. The main difference is the Run DAG job page. The top drop-down menu is the connection objects. This is required for the Airflow job to submit into the appropriate system. We also need the DAG ID as it's known on the target system. We'll look for our job with a browse feature. We'll use the configuration JSON field to set up the values to be passed to the DAG's code. Fail and pause DAG fails the Automic job if the DAG is paused in the target system. If unchecked, then the job simply waits for the active status and monitoring until the DAG is unpaused. Our DAG has 3 child tasks. If we check the child task process monitoring box, then the supervision of those tasks will be assumed by Automic to include the capturing of logs, which we can enable with the radio button below. If you enable it, you can limit the import of logs to failures only. Note that we disabled deactivation so that we're able to see the execution and monitoring after completion. Before we proceed with the rest of the objects, let's set an individual agent or host G object. Because we've set the agents, we're now able to browse the target system for the DAG. We've set up our display on a split screen with Automic at the top and the Airflow Web UI at the bottom. We can see the jobs object we just created in Automic and the matching DAG in Airflow. Let's execute our job and see how it plays out. The DAG assumes a queued status as it waits for other processes to complete and resources to become available. Let's look at the monitoring perspective. The main job, as well as the tasks embedded in the DAG, are added to active monitoring. The job is assigned a run ID, which is passed on to Airflow as an execution ID. A job report is available for the parent job. When working with the Airflow integration, we recommend using the remote status field in the process monitoring field selector. This shows the status of the matching Airflow job. The report includes the URL to the Airflow monitoring page. You can copy and paste this URL in the browser. It will take you to the matching job in the Airflow UI. If you were to view the graph page for the DAG, you would see the 3 tasks. Eventually, the DAG assumes a running status. We'll let it run its course and watch it complete. The entire workflow has completed in Airflow, which is reflected in the statuses in both environments. Reports and logs are available for all monitoring objects.
The agent log also provides valuable information should you need to troubleshoot an issue.